let's get started. My name's Karen. We did the nightlight earlier, so I'm from Springfield, and I'm going to be a senior at Union County Magnet High School. We have two mods in the chat who can answer any of your questions, Ethan and Ryan. So, and we already covered that. You can see my screen, hear my audio, see my camera. Everything's good. Alright, just a quick reminder that all children under the age of 13 should be accompanied by parents for legal reasons, and do not post any personal information here, including but not limited to full name, address, phone number, email address. And our mods will remove comments revealing personal information. Now let's review a couple of the things we did last time. So we talked about energy, and motors convert electrical energy to mechanical energy. And we talked about two parts of a motor that are in most motors, that are the stator and the rotor. So can anyone tell me which part, what the stator is and what the rotor is? Does anyone remember? Yep, the rotor is the part that spins and the stator is stationary. Good job. So we also have ways to change the output of the motor. There are two ways you could measure the output: the speed and the torque. So is the force that the motor outputs as it spins, so the rotational force. And you can change that, and you can change the speed. So how would you change? Do you remember from last time how you would change the speed of the motor or the torque of the motor? Let's start with the speed. What would you change to change the? Increase voltage. Yeah, you increase voltage to increase speed. And what would you use to change the torque? Oh yeah, there we go. Increase current. There we go. All right. So yeah, you increase the current to increase the torque output of the motor. So speaking of current, let's introduce a new concept. What we're going to be making today is a fan, and fans are typically household appliances. So that allows us to talk about DC for direct current, and AC stands for alternating current. So with direct current, as you can see in this diagram, the first picture, we have our voltage stays at this positive value, and with alternating current, it changes from positive to negative, so it changes direction periodically. Now, direct current is used in battery-powered electronics, such as the ones that we're using in this program, and alternating current is one that's used in household appliances, just because it's easier to send high voltages long distances, and yeah. Anyway, let's get into our projects for today. So let's grab our materials. Alright, cool. So let's get started. You want to grab your cardboard and your pen and your ruler. So now what we're going to do is we're going to start creating the blades of the fan. So what you can do, my cardboard is probably just the right size. In fact, you can just use any sort of straight edge. The cardboard's 5 inches should work. And I'll draw out the blades again for those of you who can see it. This time, actually, the first time I made the blades a little wide, so let's make them a little thinner this time. So you want to grab your pen, draw the blades about, let's say, 3/4 of an inch wide. Yeah, that should be good. 3/4 of an inch wide should be about right. And then you just want to draw out blades like that. And just draw a nice straight line. Just like that, creating some nice, clean blades. Alright, that should be good. And let's make them about 5 inches across, like that. And then finish this little rectangle. Again, nothing needs to be super crazy exact, because the fan will work either way. But yeah. want to start cutting out your blades then. So now we have our 3 blades right here. So we have our 3 blades, and what we want to do is we want to measure out the center of each blade. And if you want your blades to be a little longer, it doesn't have to be the center. You can do it at like 4 inches maybe if you want. I'm going to do mine at like 3.5. So I'm going to like make those dots a bit bigger so you can see them. I'll hold it up to the camera so it's a bit easier to see. So you should have dots all at an equal distance from all at an equal distance from the edge of the blade. So you want to put your pen to the hole, and you want to just poke a hole straight through the fan, and just like spin it around a bit so it's like nice and solid. You want to do that with all 3 blades. Once you have a hole in all 3 blades, you want to just lay those on your motor, like so. You want them to be like evenly spaced, so they create like a little triangle like that, I suppose. There we go. So it should look something like that, like a little, like an asterisk, but like some of the parts are cut off. So let's start taping. So you want to hold your fan in place like that, and what you want to do is you want to tape it all together. So let's just like that. That actually won't do anything. You want to tape it like this. Put those are together. You want to tape it like this. You can turn it over and tape it on the back too. Now what we're going to do is once you have everything taped, we want to make it look like an actual fan, right? So you want to carefully cut off this part. You can take it off the motor as you're doing this if that feels better. So now you have your blades of your fan all ready to go, and once you have that, you can just put it on the motor. You use your bit of tape to hold it down on the motor and tape it down. Just like that. You want to make sure it's secure because if it's not, it's going to like fly off the motor. It should look like that. It'll have a lot of tape on it, but that's okay. You want it to be secure. That's the most important thing. That should be your fan right there. So for this, before we like turn the blades so that it blows air, let's just wire it up first, okay? So we have our motor here. We have our battery pack. And we have our button. The button's kind of hard to see. Let me move that. Yeah, that's better. Okay, so we have these 3 things. And so let's grab our alligator clips and let's start connecting stuff. Now at this point, you guys know the drill, so let's just connect our, well, let's start by connecting our power. So let's connect it to our power wire. to one end of the button. Another end of the button goes to this power. So now we have our green wires, or green alligator clips, going from the battery's power to the button to the fan's power. Then we're going to connect our ground wire here to our black and our black. Alright, so let's see if this works. Oh, and it does. But here's the issue. This fan is blowing air, but it's not blowing air at me, right? So what I want it to do is I want to turn the blades just like this. So bend the blades like this so they actually blow air at you. And you want to do it in like the same direction as the motor spins. And it should also spin a little slower, which is pretty cool. Alright, so that's our fan. Alright, so because most people finished, we're gonna, well, it looks like, I think everyone finished, hopefully. We're gonna get back into our presentation. So as a bonus, I included a segment about different types of motors because we do have a little bit of extra time. Let's take a look at different types of motors. So the first one is brushed DC. So with the brushed DC motor, let's take a look inside the motor and how it works. So as we mentioned last time, we have our stator and our rotor. Our stator is the outside right here. It's these two magnets. You see like this permanent magnets over here, one north pole and one south pole, right? And then we have our rotor, which is our spinning shaft inside. It's also called the armature of the motor. So we also have our commutator, which, as you can see here, are these two little yellow things that are spinning, and each of these is like related to one of these coils. As you can see, the coils are switching from north to south as they spin around, and that's because we have brushes in our brushed DC motor, which is where they got their name from. And so these, as you send DC power to the motor, DC current to the motor, it applies charge to the commutator to change these magnetic fields as it spins around. So it's based on its position, which is pretty cool. Next we have our brushless DC motor, which is a little more complicated, but it's the basic idea behind it is that you charge these different sets of coils here, as you can see in this GIF or GIF, however you prefer to pronounce it, to pull and push rotating permanent magnets. So in this motor we have a sensor called a Hall effect sensor that detects the position of the coils, and it sends that information to something called a motor controller, which then tells the motor which coils to energize. So as you can see in the, I say GIF, but if you say GIF, that's okay. In this GIF, we've labeled them A, B, and C, right? So this set of coils is coil A, like set A, I guess, or phase A. This set is like phase B, and this set is phase C. So when the spinning, you can see, okay, this is kind of complicated to explain. Like you have this spinning permanent magnet, right? So when the north side, or in this case, yeah, when the north side approaches this, it charges up this coil so that it's south, so that it pulls it towards it, and it charges this coil so that it's north, so it pushes it away from it. So you can see that at like the beginning of the GIF. So then it does that as it changes to phase B and C. There's a really cool video that explains this in more depth. So you guys can check out that video if you have some free time and are interested in brushless DC motors, because they are really, really cool. As another bonus, this one I'm going to show you in person. It's a servo. So servos use PWM, or pulse width modulation, to determine their rotation. So this is a really important concept in electronics because it's like a way of sending signals, and that's a big part of how electronics works. So one pulse is sent about every 20 milliseconds, and the way the servo works is you can see in this diagram to the right, if the pulse width, the rotation of the servo is dependent on how wide the pulses are. So if the pulse is 1 millisecond wide, I guess, if you want to measure it like that, it tells the motor to rotate towards the 0 degree mark. And if the pulse width is 1.5 milliseconds, it sends it to the neutral position, and if it's 2 milliseconds, it turns it towards 180. So that helps the motor determine which way to rotate. Now, if you see in the diagram on the left, servos use a DC motor, and they have, I guess, 4 main parts. The motor, they have a potentiometer, which is, or in some cases with like, I guess larger servos, they use an encoder, which, the basic idea behind an encoder is it tells you the position of where the motor is. And so the potentiometer helps the motor adjust, like it slows down as it approaches the desired angle, which makes sure that it doesn't overshoot or anything. Or it makes sure that it gets to the angle that you want it to get to, basically. And there's also a control circuit attached there, which, again, I'm not going to get into the super specific details about it, but it has an integrated H-bridge, which helps change the polarity of the voltage, which changes the direction the motor spins. So then there's also the gearbox, which helps adjust for torque and speed. As we said, you can change that using electricity by changing voltage and current, but you can also change that mechanically, which is by having different gear ratios, which is something you get into mechanical engineering if you're interested in that. Alright, so now you can see the desk again, and what I'm going to do is I have with me an Arduino, which is a microcontroller, and what I've done is I've plugged in my servo with my little PWM, pulse width modulation, signal wire, and I'm going to plug in the power, and now we can see our servo in action. Ooh. So that's how it works. You can see the little gearbox inside too if you look closely. It's like over there. Yeah. So that's kind of cool. Alright. So yeah, that's basically all there is. That's essentially our entire presentation for the day. And our next live stream will be this Saturday, August 22nd, and we will be creating a little mini car rover. So look forward to that.